astrophysicist Frank Drake opened up his home to KPIX-5.
I think that the discovery of extraterrestrial intelligent life will be the most important discovery perhaps ever.
Frank Donald Drake began his remarkable career in the late 50s. It was a time when space exploration captured the nation's imagination. He became the leading pioneer in the search for extraterrestrial life.
It will enrich our civilization in a way which is almost impossible to predict. It will be enormous. We will learn things of science, of engineering, of sociology, of ways of life, of ways of protecting the climate, of ways of perhaps even colonizing other planets of a planetary system.
Among his many accomplishments, Drake is best known for devising what's called the Drake equation. It's used to estimate the number of intelligent civilizations in our galaxy.
I'm quite sure there are other sentient beings in the universe. I think in very large numbers.
Well, you've probably heard of the Drake equation. It's said to be the second most famous equation in all of science, after E equals mc squared, a formula that you probably use every other day. Well, what is the Drake equation? It was cooked up by Frank Drake in 1961 at the first modern conference on SETI, the Search for Extraterrestrial Intelligence. He needed an agenda for the meeting. That's what this thing was. And he wanted to put it in terms of, well, how many societies are out there that are broadcasting signals that we could pick up? I mean, how many societies are out there in the Milky Way Galaxy that are producing detectable signals that are going through my body as I stand here, going through your body as you sit there and watch this, okay? And it's very simple. It's like computing the number of students at Stanford University. You might not know, but if you knew how many freshmen were entering every year, you could multiply that by the length of time they stay there, typically 4 years, because most Stanford students are pretty good and they don't flunk out. All right, so that's what the Drake equation uses as its logic. So what it is the first 6 terms are how many societies that have transmitting capabilities are produced every year in the galaxy. And then we just multiply that by the length of time that they keep the transmitter turned on. That's it. So what are those first 6 terms? Well, the first term, R star, that's just the number of stars that are produced every year in the galaxy on average. They have to be the kind of stars that could have planets with, with life on them, but then that's probably 99% of all stars. Okay, but then you multiply that by the fraction of those stars that have planets. Then you multiply by n sub e, and that's the average number of kind of Earth-like planets per average solar system. Okay, what fraction of those, F sub L, develop life? What fraction of those develop intelligent life? What fraction of those with intelligent life develop communicating civilizations? In other words, they're not just sitting around there chewing their cud and reading cheap novels. They actually build transmitters and receivers and stuff like that. Multiply those first 6 terms together and you get the number of new civilizations produced every year on average in the galaxy that have the ability to transmit. And then the last term, L, is the number of years that they stay on the air. All right. So that gives you, how many societies are out there. And if that number were very small, you would say, well, maybe SETI isn't such a good experiment because we're never going to find anything. If that number is very high, then you can say, well, maybe SETI's a really good experiment because we're going to find something fairly quick. All right, well, nobody knows what most of these terms are. I mean, we know some of the astronomy terms, but we don't know things like what fraction of planets that are kind of like the Earth, eventually produce life, let alone intelligent life. Or how long does a technologically sophisticated society stay on the air? Maybe they invent radio and then, 100 years later, they invent the bomb and they blow themselves away. I mean, we don't know, but it's a great way to organize how we think about these things. And that's why you'll find the Drake equation in the last chapter of almost every astronomy textbook you can buy.